So energy average power dissipated across the circuit is, it is dissipation happens only in the resistive part. So it is Im square into R, IRMS square into R. IRMS equal to Im by root 2. So Im by root 2 the whole square into R. Okay. So energy dissipated in the resistance is IRMS square into R. And IRMS is equal to peak current by root 2, Im by root 2 the whole square into R. And energy equal to power into time. So if you want to find the energy, so take the power multiply by time. So Im by root 2 the whole square into R into capital T. Since I am taking for one cycle, it is only for one cycle, so I am multiplying by the time factor capital T. Energy equal to power into time. And in the formula you see it is involving energy. But for inductor I have found what is energy stored. But for resistance we find the power. So if I want to convert power into energy, I need to use the formula energy equal to power into time. So power is given by Im by root to the whole square into R into time capital T. Now substitute everything, and I am writing time as 1 by frequency. So it is Im square R by 2f. Okay, I am writing time as, time and frequency are inversely related. So I can replace T by 1 by f. That is what I am doing it here. So see the next one, Im by root to the whole square into R into 1 by f, or Im square R by 2f. Now substitute everything in the Q factor. Q is equal to 2 pi into maximum energy stored per cycle. What is the maximum energy stored per cycle? It is half L Im square. Half L Im square divided by maximum, energy dissipated per cycle. So energy dissipated per cycle is Im square R by 2f. Okay. So Im square and Im square will get cancelled. So this 2 and 2 will get cancelled. And 2 pi f is omega, remaining L by R. So you get omega L by R. And omega L equal to XL. So Q is equal to XL by R. So if you use the first formula, Q is equal to X by R, we have to replace X by XL. So directly you will get the answer Q is equal to XL by R and XL equal to omega L. Okay, so this is the quality factor of an inductor. So for an ideal inductor, the resistance value will be 0. So I can say the quality factor will tend to infinity. Practically, this R value will be taken care to make it as small as possible. So the Q value for an inductor, practical inductor, will be very, very large. Okay, so higher the Q value, the better is the device. So when you go to buy inductor or capacitor, you should not see cost as the main criteria. You should check for the quality factor. And this quality factor depends on what frequency you are operating. See, the omega term is coming there, right? So it is a frequency dependent term. So what frequency you are operating the inductor, at that frequency, the quality factor has to be found. That will help to find whether that inductor will work properly at that particular frequency or not. Okay, so Q factor is not a constant term. Q factor is a frequency dependent term. And as the frequency of operation will increase, the Q factor will also increase because Q is proportional to omega. So if you use the inductor at a very high frequency, it is intended to give a better quality factor when compared to the usage of same inductor at the low frequency. Okay, so so we have found the quality factor inductor. So any doubts in this small derivation? Anybody is having queries so far in today's class? Again, we are just revising all these things because these formulas will be used in the derivation of single tuned amplifier. So whenever term omega L by R comes, you should recollect that it should be replaced by Q. For that only, we are deriving the quality factor of the components L and C.